All right, let's go. Britta, you ready?
Well, if I can activate the microphone, I'm ready, yes.
Perfect. So I would say let's give it a start. Welcome everyone to this tech talk called AI Discovers Cost for Scrap and Complex Variant Production. My name is Makarana and I'm a venture development lead at Park. On behalf of the entire Park team, I'm very happy to welcome all of you and also welcome you, Britta. Thank you already for taking the time to dive into that really interesting topic. I'm really excited to learn some new parts of AI and see another application mode about it. I'm also very happy to see our members joining in. So for those of you who are not members of Park, I'm going to really briefly explain what Park is and what you dialed into. So about Park is a non-profit organization. We were found about 1.5 years ago from 12 leading organizations. Last year, about one year ago, approximately, our office opened, and with that 12 founding members started. We have now accelerated within 1 year to 103 members already. If you look at the logos, you will see we are a diverse network. We do have larger research organizations, we have political organizations, we have a lot of startups from small to scale-ups really large. We also have them based in Germany, all over Germany, but also in our neighboring countries. You will see some in Sweden, some in Belgium based. So this is really an international network, and this is also our goal at Park. Our mission at Park is to foster and accelerate AI innovation. We want to create new AI innovation and be the platform for people to join, discuss about it, and really get going and bring about these innovation in that fields. We're having a focus on AI, but we also are having some robotic focus. We're also having focus on quantum. So this is a rich and data-driven and highly technical network that we're having. So what are we actually doing at Park and where are we based? Here, if you're not familiar with Berlin, this is the city center, and we are based right between the city center and the airport at Mariendorf in that park that is going to soon flourish as a new cluster for AI tech innovation. Our office is behind that tree right here if you haven't been to us. If you are in Berlin, let us know, come by, approach us, meet us, and we were happy to show you our space and tell you more about Park. So what are we doing? We're doing a lot of things. So how I cluster it usually is 5 things. At Park, you are going to meet and make the right connections. We are having contacts to VCs, we are having contacts to corporates, we are having contacts to other startups, as I said, a lot of cool people to meet who are experts on AI or applying AI. So it really creates a good opportunity to mingle. And then second, we're doing joint projects. We're bringing people together in order to work on AI. There are programs that we are launching, but also there are projects that we already do. And then by joining our network, we are pushing you in terms of visibility. We are quite active on LinkedIn. If you don't follow us yet, do it. We have a newsletter that is quite frequently subscribed to. And then, of course, we're doing these events like the Tech Talk, where you can showcase what you are doing with AI already. And then lastly, as we're having a lot of experts who are willing to share their knowledge, it's about learning as well in that environment. So a lot of expert in that you're gathering. And as we are an NGO, we are well connected. We speak for our community, and a lot of opportunities within that larger ecosystem are approaching us. So we are sharing them amongst our members, whether it's about funding opportunities, whether it's about award ceremonies, whether it's about conferences, all that reaches us and we're distributing it. So helping you in order to stay updated, as it will, if you will. So that was really brief at Park. If you'd like to learn more about Park, feel free to reach out to us. Feel free to reach out to me directly as well. And that being said, I think we are here already for the topic. So I'm very excited to introduce to you Britta Hild. Britta Hild is the co-founder and managing director of ES Predict, based in Saarbrücken. And she's going to talk about AI discovers cost for scrap and complex variant production. That being said, Britta, I would say the stage is yours. Really grateful to have you and excited to learn some new parts about this. So I'm going to stop my slides now. Oh yeah, it already stopped and you can take over. Thank you for having me.
Perfect. I have already taken over, Mark. Thank you very much for all of you joining this Tech Talk. My name is Britta, as mentioned, Managing Director of company IS Predict. And I would like to give you some experience we have gathered, how artificial intelligence can help you in order to improve quality in production. There are two keywords, self-learning, explaining. I will talk about this later. And just a very brief information. As you can see, I come closer to the camera now. As you can see, I'm not that young anymore. And that is why I actually can give you some insights from several projects we have done. And I will talk most of this first project about transmission production, and then I will talk about other projects, but very briefly, because the principle is always the same. So we have been in different companies, and what we have seen there in those companies, nobody is saying, oh, I want AI. AI should help me. I mean, maybe the chief digital officer is saying, yes, we want to do something with Internet of Things. We want to use digitalization. How can it benefit us? And actually, there are two major requirements, which again and again are popping up in complex production, in complex processes. And the first requirement is that actually you should, AI should help you not just for a couple of months, but in complex production processes are changing again and again. So there are new types of welding spots, there are new types of variants of your product, of transmissions, for example, of gearboxes, and AI should adapt to those changes. I mean, like we humans, when we learn something, it is never exactly the same situation in our life, but we can remember and we say, all right, we behaved in this way, that was good, so let's now do it in a similar way. And that is exactly what our clients also request from AI, from artificial intelligence, as human intelligence does it. It is not do exactly the same, but do that what is appropriate for the changed situation. And that is one thing which is more and more difficult the higher the complexity in your production processes is. So normally in automotive supply, you have high variant production. So that is one requirement. And the second requirement is, I do want to understand why AI is recommending this. I mean, the people we are talking to, of course, they are not data scientists. They don't want to understand the mathematical models behind AI, but they want to understand it from their point of view, from their domain viewpoint. And that is exactly what they say. We want to trust that AI, so we want to understand how it, well, in inverted commas, it thinks. And that is exactly those two things, or two major requirements. We saw the more complex the data is getting, the more complex the processes are getting. And now when you think of the title slide, I said there are two words, self-learning and explaining, and I will come to that later. Now is the moment that I come to that, because AI should adapt to process changes. How can we do that? We have developed self-learning algorithms which adapt automatically to changed situations. That's one thing. And the second thing is, I want to understand how AI thinks, in inverted commas, and that is where explainable AI is required. And that is exactly what I would like to tell you about, what I would like to show you in those client project examples I have selected. So let's get started right away. It's an automotive supplier, an international automotive supplier, which produces transmissions or gearboxes, and it's always more complex than you think. The number of parts, the maximum number of parts of a transmission can be 600 parts in a transmission. And what I was also surprised, I mean, they have 17 basic transmission types. That's what I would have thought even without talking to them, but they have 700 variations. And nobody wants to do variations in their production, but they have to do it because their clients require it. And that is why it gets really, really complicated, up to 600 parts, up to 700 variations. They have different suppliers for this little wheel they require. They have maybe 50 machineries doing the same production steps, so it's high variation. And the problem is, what they said is that sometimes, of course, each of the transmissions is tested at the end of line testing is mandatory. And sometimes transmissions fail, and then they try to fix the problem on that complex transmission. But if it increases, or if the number of failures, of end-of-line testing failures increase, today it's 1, tomorrow 2, a day after tomorrow 5, 10, 20, then you think, what is the problem? What has changed in production, getting this gearbox together? What has changed? And there they said, we would like to understand, we would like to find the reason why the gearboxes do not pass the end-of-line testing, and the focus was on noise testing, because noise can be everywhere. You know, this is a complex device, and noise can be created almost on each part. So why did it fail the noise test, and what is the reason in production? What went wrong? I mean, a week everything was fine, and suddenly another week it does not go well. And the data we received was, of course, as you can see here, from the end-of-line testing, from the test bench. So the noise level, the limits, the setups. But we also received, going back to the production, the assembly and pre-assembly data. And we got information about the manufacturing. Some parts they manufactured on their own, and other parts they bought from suppliers. And we got the information which supplier in which batch delivered which part, and on which machinery did it go through. So traceability was available as well. Now the complexity, why did they start that project? Because there is a very high complexity. And what they told us is that, of course, speed, as you see at the last bullet point, speed is important, because manufacturing goes on 24/7. And if you are at the end of line testing, and then you notice, oops, there is an increase of failures, of noise test failures, and what is the reason in production? You need to find the reason soon, because you know that it is moving towards end of line testing, and then you will have still those problems. And they said sometimes every morning they meet, and then they see what happened yesterday. So how many end of line testings failed, and are there focus areas, and then they try to find the root for it. Maybe a tool which was already partly in wear and tear, but please keep in mind they produce 11,000 transmissions a day, so it's a large plant, and the plant has almost 1,000 machineries. Now, where to look at? Where's the reason? And it's noise testing. So it could be caused by any part of those almost 600 parts in this transmission, in this gearbox. So they said it's much too complex. And sometimes they were looking for 1 week to find the problem. And suddenly it disappeared, which is a good thing. But when the problem disappeared and you do not understand why, then it can happen again. So maybe it was a special batch from a special supplier, and in combination of tear and wear with some machineries, the problem occurred. So it's a very complex thing, and they said, well, we need support here. And the key, what they wanted to have, is they wanted to reduce waste in certain manufacturing domains by 20%. And that was a figure, but I'm pleased to let you know that we achieved it. But how did we proceed? So just to give you a very easy picture of the manufacturing process, as mentioned, it's almost 1,000 machineries, but of course they have manufacturing, they have assembly, and then they have testing. And you see they have different lines. The material they produce, it comes into buffer, and then maybe the buffer that one what you put in the buffer first, of course, then it is when it's emptied, it's last. So there is quite some variation in it. And you see at the assembly, you also see that line 4 and 5 are actually moved a little bit away, because that is on a different location, but it then comes back to the end of line testing. And all end of line tests, they have 11 test stations. The test benches, they do those many tests, and among other things, they do those noise tests. And of course, they have special equipment there to do the noise test, and in the end, it says good or it says bad. And if the noise test failed, well, first, actually what they do the test again on the end-of-line testing machine, and if it then still fails, they actually move to another end-of-line testing machine, because the machine could be wrong as well. So they have different checks, double checks, But then if it still fails, they say, all right, what should we do now? Of course, we need to solve the problem on this gearbox for sure, or it is scrap, but normally they fix it. But where in those almost 1,000 manufacturing machines, where is the problem caused? And that is really, really hard work, as you can imagine. Now, how did they proceed? Every morning they have meetings. They have oh no, I need to say it in a different way. Every night there is a batch run based on the end of line testing results, and the statistics is generated. How many tests failed? Is there a focus area? So is it noise testing? And if yes, which part of noise testing, or is it something else? And they have a meeting for the different functions. And here they have the acoustics meeting, because that was focusing on noise testing. And then they said, all right, let's have a look at the statistics. In this meeting, people from different departments took place, because it is an end-to-end analysis meeting. So then they had a look at the statistics and said, all right, have a look, we have a trend here. You know, Monday was so many failed, Tuesday so many, Wednesday, so it is increasing. Something must be wrong. What can we do? And then, of course, you don't have as many people as you would like to have in your office, in your production side, in your logistics. So, of course, they need to prioritize. They prioritize which are the largest pain points, or which are probably going to be the highest numbers. And based on that, they say, all right, let's focus on that and that. And then they go into their production process, which is the manufacturing areas, the assembly, pre-assembly, final assembly, the end-of-line testing. And then they try to find the problem for that. And on the next day in the morning, they have it also always every workday in the morning, they have a look, what is the result of the 24 hours end-of-line testing as far as noise testing is concerned? And is it good? So we don't need to do more, or is it kind of the same problem, or is it even getting worse? And if it is getting worse, or if it is the same, of course, then, you know, the loop goes back, focusing, where should we prioritize, what could be the problem. Then they go to different production machineries. Maybe they measure if the dimension of the tool is still good for critical production steps, or whether tear and wear is proceeding, and maybe you should exchange a tool. Maybe only in a combination, just to give you an example, only in a combination, almost 600 parts of that gearbox, and maybe just a little wheel, a metal wheel, which comes from a supplier A. And the supplier, of course, has specifications that the size of the wheel must be within certain diameters. But maybe normally the size is on the lower end of the specification, and this batch from the supplier is on the upper end of the specification. And maybe that combination, if you have process step 500, and there they have, for example, 50 machineries doing the same job, if this little wheel is then processed on machinery 50 only, then you cause the problem in the noise. Maybe on machinery 1 till 49 for the same production step, no problem would have occurred. So it's really difficult to find this, and that is happening every morning. And for example, for the acoustics problems, in order to find it. And that is why they said it's so complex, so let's do it in a different way. And you know, see, the process is kind of still the same. Of course, it's still people meeting each other from different departments, meeting in the morning, taking action, and then getting feedback on it. However, AI is recommending when a transmission is failing end-of-line testing on noise testing, then they press a key, and then it takes a couple of minutes in order to analyze all the data of the parts, of the traceability, on which machineries was it processed. Sometimes there was some machinery data, actually, not only it was processed from timestamp 1 till timestamp 2, sometimes it was more data, but not often, because it's almost 1,000 machineries in their plant, and they are old. They are not all brand new. They are not all IoT enabled. So yes, it was a lot of data, but for each machinery, it was often just on-off timestamp, when did this little wheel pass through. However, analytics takes a couple of minutes to analyze and find dynamic data patterns in order to recommend where should you focus on, where should you make prioritization, and where is the cause? So go to production step 25, for example. And depending on the details of the data, sometimes the analytics could even pinpoint machinery 1 or 2. But normally it was a production step area. Then very important, you get feedback from the quality engineers in order to say, yeah, exactly, it was the tool was already quite in wear and tear. And that is actually how the solution runs. However, what we have noticed during the project, they said we have a data lake. They have spent a lot of time and money before they met us in order to get their machineries, at least the data which is existing, connected and having it in a database. So data lake was there, but we noticed a different thing, and they were surprised, but it was logical that they didn't take care of it because they had never used that data end to end before. So they have different production lines. And if there is one process step 50 in production line A, and you get data, then maybe Mr. Miller is responsible for that production line, and then this data is called ABC. In production line 2, doing the same production step, it is Miss Smith which is responsible for the production line, and she's calling it not A. This data point is not called A, but is called B. Then you get everything in your nice data lake. You have a lot of data, but the semantics do not map. So actually A equals B. And to be honest, that was something we in that project also underestimated. We underestimated that it takes that much time and discussion with domain experts in order to get the semantic mapping done of the data, which means the same, but is described, defined in a different way. And that is exactly why we said, well, now we have done it, but from a strategic point of view, if you get new data in, so if you transform you have digital transformation and you get new machineries, and then you get this into your data lake, make sure that the quality is fine right from the beginning. And of course, as you see on the right-hand side, the operative data quality. And that is why it was not only focusing on this, but having also information if AI notices that something is not correct on the, let's say, strategic data quality, the digital transformation for data quality, we called it. And that is where semantic checks, consistency checks can also help. And then, of course, the engineer gives again input and says, all right, this is done, this is semantic mapping so-and-so. And the same is with operative data coming every day. If certain sensors are, that stuff, if certain sensors are not giving values, there are gaps in it, or they give values, but they are really, really strange. I mean, sensors can have errors as well. So the right-hand side, I would say, is the normal stuff. The normal stuff when we do AI projects. The left part was really because it was focusing end-to-end production line, and then you have cross-line, cross-responsibility, and then you have different people defining the data points, and that is where you need some rules, or let's say someone who takes care that it is defined in a consistent way. And that is why this additional aspect was also considered. And of course, on the operative side, if AI notices data is missing, values are not logical in this context, that's something maybe I should mention as well. Of course, values can be 0, 1, 2, 3, whatever. And maybe sometimes 0, 1, and 2 are normal values. But in certain contexts, considering the material, considering maybe the supplier, considering how it processed the traceability, how it processed on the different machineries, based on that, maybe 0 is not a good value or not a logical value. And that is exactly where this data quality is done as well. It's not done on fixed rules. It is done on dynamics, on dynamic data patterns. And that is why fixed rules in that case would not help, because sometimes one value, the value 1 is nice, is good, is logical, and sometimes the value 1 does not make sense. So it's when you get complex variant production, for sure, all the work around it gets complex as well. Well, now having talked about that, let me talk about self-learning, because I mentioned it in the beginning that clients want self-learning. They are not coming to us and say, we want self-learning. But what they say is we have complex processes. We have a world which changes again and again. We get new suppliers, we get new specifications, and only little welding spots. I will talk about that later. Little welding spots which melt together metal in a car body. The client, an automotive client, has hundreds of welding spot types. That there are hundreds and hundreds of welding spots, of course, that's logical, but types, which means it is always much more complex. And here you see the complexity from that client who produced those transmissions, 700 variations, up to 600 parts, up to 50 machineries doing the same job, doing the same production step. And the client said, in order to manage that complexity, we would need an army of data scientists to always adapt to our changed reality. And even if they had all budget in the world, and even if they would get those data scientists, you would always be one step behind. So they said we need a solution which we can then roll out, which we do not a second army and a third army of data scientists. And that is exactly why they said what we need is self-learning, which adapts automatically. And I guess you see my hands. If this is reality, a robot is doing something. This is the famous digital twin, although I call it digital shadow, because in a twin you can see everything. In a shadow, you should see enough. So if that is perfectly fine, you have your reality, you have your digital shadow. But if your reality changes, you need to adapt. And if your reality changes all the time, that is exactly when you would need that army of data scientists. Now, coming to the results, what the client confirmed us is that around 3/4, well, I have to say the results are based over 2 years, should say that first, over 2 years. And when the production was done, as you remember, each transmission is actually tested in end-of-line testing. And if noise test failed, then they press the key. So not for each transmission, obviously, but for each transmission which failed noise testing. And they pressed a key, and then it took a few minutes, and the analytics said that production step, where is the root actually caused. And then they confirmed in 3/4 of all cases, they could validate it. They could go to that machinery, go to the production step, I don't know, measure the dimensions of the tool and say, oh yeah, this is here and where we actually replace it, and then it works. And then it worked fine. So in 3/4 of all cases, they said 100% understand. You could confirm it. In 1/4, they actually said, well, we cannot confirm it anymore. We cannot validate it anymore because the tool had already been exchanged, for example. You know, it's in production, it takes time to produce the gearbox, and then we have the end-of-line testing. And then they press the key. If it fails, the analytics starts, and then the person, of course, needs to go to that place, which means all the time you're in production, maybe that cause was already recognized, or the machine operator said, oh, something is wrong here, I need to do something. And that is why they said we cannot say 100% that it's true, because the tool might have been replaced already, but it sounds very, very reasonable. And I'm also pleased that they made this differentiation, because in that case, of course, you see, they said we do not just trust AI. We are not blind and trust AI. We want to understand it. And validation, I believe, is a very, very important thing in order to trust. And it was the result over 2 years. So that was not just if you see my hands, reality is still the same. Over 2 years, there were a lot of changes happening with the data. Okay. So that was a quite long explanation of the project for automotive supplier producing transmissions. Now I would like to give you some other examples, but I make them much shorter. They are also from automotive supply, and they are from process industry. And here it is about robots in which weld metal car body together and other metal processing. And then I actually want to go to another industry, because everybody normally talks about AI in manufacturing, in discrete manufacturing, automotive supply, but I would like to show you examples on process industry as well. So let's still stay with automotive supply. Oh, sorry, with automotive. So this client is producing car bodies, truck bodies, and of course they have a high automation. There are a lot of robots which are moving the metal, putting it in the place where it should be, but also doing the welding spots. And as mentioned before, they have hundreds and hundreds of different types of welding spots. And they said, we have a very high complexity, very high variation of welding spots. And they said the welding gun, which you see here in the picture, which is doing those, which is melting the metal, which is doing the weldings, they have of course they have a software, it's controlled by a software, and the software is also giving a quality KPI, but it does not fit their reality because they have a very high variation in their production. So they said, we need something else to make sure that the quality is good. What they do anyhow, I think they do it out of ISO certification. They have manual checks now and then, but that is 1% of all welding spots, or maybe 1.5% of all welding spots. So it's not a lot. And why is it not a lot? Because it's people, it's humans who need time, who need special expertise, and who need special equipment for that. And every so and so minutes, the car needs to leave the assembly belt, so you don't have much time. Time is money. And that is why they said out of the data, and the data was per welding spot, not a lot. It was a kind of 15 target data values and 15 actual data values approximately. Out of that data, they said we cannot install additional sensors. That's something people always say, we cannot just do retrofitting. I mean, we have hundreds of robots. Sensors, installation, connectivity, that all costs money. We want to have the analytics with that, what the machineries gives you. And per welding spot, as mentioned, 15 target values and around 15 actual values, but several hundred welding robots, and almost every second a robot is doing a welding spot. So big data indeed. And here 100% check is possible. And what the analytics is doing, it's actually the data comes into the database, the analytics analyzes on edge, it's on the edge infrastructure at the robot cell on an industrial PC, it analyzes good, not good. And if it is not good, then actually the value in the database, not good, triggers the process, triggers the MES system in order to phase out the car body. And the client said it's important that this phasing out is happening fast, because you cannot, they do not want to phase out this car body if it has already moved to the next robot cell. So the weldings are done, dip, 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 and then analytics must be ready to phase out. I would not call it near time, real time. I would call it near real time, because it takes some time from the welding gun to get the data into the database, and then milliseconds do the analytics. That is runtime, and I talked about continuous learning. That is not on the edge. Continuous learning is normally on a central server, and that central server is understanding, and if you see my hands, adapting automatically. And that is what the client said, this adaptation must be done on the fly. We cannot stop production line. I read a figure in a research, not sure if it is true for all automotive clients, but they said in this figure, they said 1 minute of unplanned shutdown is around 25,000 euro. And they said we do not want to stop our production line just for this adaptation. So it must be done on the fly. Next example, it's about metal processing automotive supplier. And it's about injection pumps where spindles shape outside and inside. And here the client had, here we're focusing just on that production step, and the client had around 20 or so machineries which are actually the same. There's the machinery, the processing machinery are from the same supplier. They are set up in the same way. They do the same job, but sometimes one machinery has worse results, machinery number 20, and sometimes machinery number 1 has worse results. So the question is, why is that? And what they actually wanted, as you can see here in the title, they wanted the prediction of the quality, and they wanted to understand why is it happening. And just to give you a feeling, a welding spot I was talking about takes a second or two. Here the production step takes much longer, around 60 to 70 seconds. But they said they would like to understand it early in advance, but on a reliable basis. Early in advance, and we were able within 30-40 seconds range, so let's say a little bit more than half the processing time, to predict the 11 quality KPIs in a very reliable way. And if the prediction already said this is not going to be good, this is already scrap for sure, then they wanted to stop the machinery. Why should you spend 20 seconds for scrap? I mean, use the machinery, processing time, the oil of the machinery, all is money. And also to understand why things are happening, so recommendations could be given to the machine operators. That was now examples on manufacturing. Now, quick example in the last few minutes on process industry, because they have complex variant production as well. And this is from a client, you probably know, the building material, and the figure they gave us, we are allowed to talk about, as you can see, in the end-to-end production to build boards where you can build walls inside your house, for example, they have 5,000 influencing parameters in their production, and it takes around 2 days until the product is finished. And they said, we do not understand, sometimes the quality is not good, but according to our knowledge, all the production parameters, everything, the suppliers, everything is the same. So why is sometimes the quality not as good? And I mean, those boards they do, the plaster boards, they are also on the floor, and of course you put a lot of weight later on it, so it must be very strong. And they said, we want to understand what is the reason for bad quality. And to make a long story short, around, oops, that was not me, that was PowerPoint. Out of those 5,000 influencing factors, AI was possible to focus on or to discover complex and dynamic data patterns in order to mirror down to 20 parameters. And 20 parameters, 20 influencing factors is something people can work with. If you have 100 or 200 and say those are significantly relevant for bad quality, what to do? But 10, 20, 30, that's something they can focus on. And here they also wanted the trust. What is AI saying? So does it make sense that it says it? And here that is why we also did a prediction. So the accuracy, how solid this board is, that is one key quality KPI, was about 97%. And that was the moment when people said, all right, we trust it. And then the analytics, because we use semantic networks in deep learning, we do not use neural networks. We use semantic networks. They are explainable. They discover and let you know what are the significant influencing parameters. And my last example, also process industry. Here it was about cement production, and here it was also, make the story short, in cement production you have a large machinery cement mill, and it also depends on the experience of the machine operator, how good it is, especially when you change from one batch to the other. You have a middle quality suddenly, and you want to get to the accurate quality again. And how did we proceed? Of course, predicting the quality with a very good accuracy, and then the clients can trust it. And then it is actually control. Here in that case, it's giving recommendations to machine operators. In other cases, it can also be automated control. So those were various examples, and let me just sum up. In a nutshell, it is very important is, where's my mouse, that it adapts to changes and that it tells you what are significant reasons for bad quality, for high tear and wear or whatever. Topics I have only discussed about quality. networks, and I have just talked about some clients, but there are more. Now the time, I'm almost in time, 2 minutes over, but now I hand over to Mark again.
Thank you very much, Britta, for this really interesting presentation. I think you can go on, and you delved in so many different industries. It was quite impressive already. If you guys have questions, please write them down into the chat while I'm reading out the first question from Clemens Schiewig. I think he already left, but he said like reach out to him afterwards.
Okay.
So his question, as it might be relevant still, is whether the entire test already been digitized, like pipelines, etc., set up. If so, that would be better than most customers in my experience, or was it Excel as a database?
Well, no, they had a quality database where the test benches, they have several test benches where all the data is available. So I can't say that it is 100% digitalized. That's what I do not know. But they have a testing program. And at Knauf, for example, it was more like a table, but I'm not sure if it was Excel at Knauf, to be honest. But for sure with the transmission, and I guess that is where the first example project I talked most, spent most time. For sure, they had a proper QA program, and all the rules for their testing, the limits they defined, and the results went into the database. So I guess at least a lot is digitalized, or can't say the word, you know what I mean.
Yeah. And then also Clemens made a comment on that issue that, you know, one team calls some data labels differently than others, as that was a data governance challenge that you faced.
Yep.
How, I mean, I found that point really interesting. What was your role in navigating through that data governance challenge? Were you in the kind of dealing between these two teams and aligning them, or did they do it themselves? How was it?
Yeah, well, actually, we didn't plan this task, but then we got this data and we thought, production line A, B, same production step, can't find the data. And then they said, oh, it's the same, it's just named in a different way. And then the task started. And actually, we were the ones who pointed them. Yeah, we guided them, let's say. We did not look at all the data in the end because it was a lot. But then we showed them some examples. We discussed it with the different teams. And they said, all right, yeah, semantic mapping. And then actually, we guided them, but they did the semantic mapping because we don't know each data point. So the domain experts needed to do it. It was more work on the domain expert side than on our side, but it was a task we had not planned.
As always with projects, right? That these happen.
That's what it is.
Yeah, so I like that human part of it too. And you were like, you had these touch points all over these data analytics phase. I found it super interesting. I mean, as a general question, maybe what experience did you make that these machine operators or quality managers somehow then got recommendations from an AI? So did you have any insights on how they are dealing with that and how they reacted towards that machine telling them how to do their work in a way?
Yeah, well, actually, of course, there was a kind of, which kind of project is starting now? But there were, not each machine operator was involved in the project, but let's say the project team leader, they were involved in the projects. And what was really the difference is, now I make another red circle here, what really makes a difference if AI explains why it thinks this. Of course, AI does not explain it all the time when you have operation going on 24/7, but in the project, then normally when we say AI recommends this and these are the reasons for it, you know, that is then actually when you discuss with them and when they say, and we had experience where in one project there it was about energy and a dryer in wood production, it was about energy savings, where they said, it was about finding the reasons why sometimes there is more energy required for the same output. And then the people were sitting there and said, no, this cannot be true. And then I wanted to write the invoice. So I thought, is this going to happen? But then the colleague, the data science colleague, which was leading the meeting, said, wait a moment, we dive down in the data, have a look at this time period, that so and so and so influencing factors. And then from this behavior, they changed in that behavior, still wrinkles on the front head. And then I have to say, it was one of the younger guys who said, wait a moment, if that is true, how could this be with thermodynamics? You know, it was a triad, thermodynamics, and I didn't understand a thing. I was not good in physics. And then it was about 15 minutes discussion. And then they said, all right, yes, yeah, that could be. And I think that was a really good hand-in-hand experience. Data science, domain experts. And I'm sure if that, yeah, well, I don't know. I guess if that younger guy had not said, wait a moment, let's think about it from a different viewpoint, if the older guys, I mean, I'm older, I'm allowed to say that, if the older guys would have stayed like this, the project would not have been successful. But in the end, the project was successful. We got the reference. They were happy, but only because, in that case, the younger guy had a view from another viewpoint, thinking from another viewpoint, and explainability, because we could dive down in the data and show what the semantic networks are telling or are finding out. So it is explainability, I think, is the key to trust. Maybe after half a year, everybody says it runs so well 24/7. I don't care about explainability, but in the beginning, for sure, it's important.
Yeah, that's an experience we also encounter a lot of times. It's actually one of the pillars also at KPAC. We are putting explainable AI and these things. It's really key, I think, right now to get it. You touched on a point that is also very interesting, probably to the manufacturing industry right now, is energy consumption, which is quite energy intense. And you now focused on quality control. How did you like, was energy consumption at all an issue, or do you have similar projects that are operating on these issues?
Yes, energy for the last couple of years, of course, energy has been an issue, but now we are getting more demands. Surprise, surprise. And of course, especially in energy intensive industries. So in steel plants, where the oven heats up to 1,500 degrees, I think. But also like in wood production, where you have dryers, or in building material where you have dryers. I don't know what the heat is of those, but of course much less than 1,500 degrees. And what they want to understand is, like I showed you, like in quality, they want to understand which energy will we require. That is especially in high energy industry, when they have special contracts with their utilities and they need good predictions for that, or if they use more and more renewable energy, which is not reliable because wind blows when it wants and sun shines when it wants. So to get a better planning, how much energy will we require when? But also why, that was my example with the dryer, with the wood, with that guy, with the wood production. Why is it sometimes more energy, although the machinery, the circumstances, the output, the quality is always the same? So what are the disturbing factors, like with the transmission project I showed you? And up to giving recommendations to machine operators. I mentioned cement industry with recommendations for machine operators for quality. And we had another client there, it was about energy. Cement, they told us, of course, different operators work in a different way. Like we drive cars. I'm older woman, I drive not very fast. My younger colleagues drive much faster the car. I'm more secure, I believe. But anyhow, but that is the same with machine operators. Machine operators, some are very risky and others are more reluctant a little bit. And some require much energy for the same output and others do not require that much. So that is one variation. It can be on the circumstances, on the weather, on the production, many variations. And here recommendations are also important. Recommendations to machine operators. And actually they told us that is a lack of missing qualified staff, and that people normally do not stay 20 years at the same company anymore. I mean, the old production guys, maybe they just hear something and say, oh, something is wrong, I need to change the settings of my cement mill. But younger people nowadays, you stay a year or 2 or 3, then you go to another company. So they want to keep the experience which the guys have learned over 20 years, and the experience is in the data. How do they control the cement mill? And this data is available, and then AI should give recommendations. So it's the same story to make a long story short, it's the same story on energy, prediction on energy, like prediction on quality. It's root cause for high energy or for bad quality, and it is giving recommendations to machine operator to have good quality, to have less energy.
All right. Thank you so much, Britta. Last quick question is, how can we reach you? The very end.
Moment here.
Perfect. Perfect. That's interesting. So yeah, probably people can also reach out to you via LinkedIn or so. I think we have also tagged you in our LinkedIn channel, in our post that we did regarding that one. If you guys want to re-watch all the information that was really dense in that tech talk, we are gonna upload it soon, probably next week. We're gonna upload it maybe also by this week so far, so you can rewatch it again and have a look at the details. And if not, of course, I think Britta can delve much more down in a personal conversation. So reach out to Britta as well. And yeah, I'm gonna share my slides for one quick
I have
time.
one final
Yeah.
remark, Mark.
Oh yeah, sure.
Because you mentioned it. I mean, if you want to follow our social media channels, of course I do marketing for that, but I promise normally we only post once a week, and normally we post project examples. Now and then we post when we go to an event, but normally it's project references. So feel free to book our channel. Now, Mark, you can go on.
Awesome. So yeah, to the end of this tech talk, I just want to get you an overview about our next event and opportunities to join. So there is in Berlin, end of July is going to the We Are Developers World Congress happening here in Berlin, and we are going to do a meetup that is happening 2 days before with another startup called Pacemaker. It's going to be also about AI, and it's going to be really techy at this one. So if you are a developer, if you're interested in AI in general, or I would say a tech-savvy executive or so, join that one and mingle around with others personally here in Berlin. That's one event. Then there's going to be a next open house event that we are going to do in September. It's also a networking event where if you haven't been to KI Park, we will show you the space. We'll tell you more about what we do. And of course, you can meet more of our members as well. And then lastly, we always face and encounter people that are approaching us with new ideas and not aware about AI. We are going to do a workshop which is about identifying use cases, and it's going to be an online workshop which is taking place also beginning of September. For those of you who might want to dwell a bit deeper in AI and who want to look into what AI could bring to their company and organization. So this is going to be in September. We're also going to do it with a partner involved. All of information about this event are going to be shared on our website, are going to be also communicated in our upcoming newsletters and in our online communication. So feel free to subscribe to them and be aware about these next events going to happening. As I said, also if you like to get more information, make sure to sign up our newsletter. I would say this is the most accurate and most dense compilation of our news in our ecosystem. I think the next one is going to be sent out beginning of July. Yeah, of July. So feel free to subscribe. And that being said, thanks again to Britta for your amazing tech talk. Thanks for sharing all that industry in expertise also on AI. And I'm really happy to have you. I would say the last words are yours to close it down, and then I think we are good to go before lunch.
All right. Well, I thank you all. Have a good lunch and have success, fingers crossed, in your AI projects. And it's worth working with the data. Go for it.
Awesome. Thanks so much and see you soon. Bye-bye.